creature, Pachycetus, is a whale. It might not look anything like today's cetaceans, but this is where it all started 50 million years ago. The key feature that links it with modern whales is the structure of an ear bone. This ossicle is thick with bony walls, and it indicates that it was adapted to a semi-aquatic lifestyle and is transitional between artiodactyls and cetaceans. Another more recent transitional fossil is that of Ambulocetus. This was predominantly aquatic, and fossils were heavily associated with marine plants and mollusks. However, isotope analysis of their teeth indicates that it still had close ties with freshwater habitats. And if you look at the body, the skeletal structure indicates that it would move up and down as it swam, much like modern whales, although perhaps with these close ties to freshwater and land, perhaps a more comparable analogy would be otters, and this is in stark contrast with fish and crocodilians, which move side to side as they swim, and these certainly would have shared the waters of the Eocene with Ambulocetus. Much like Pachycetus, Ambulocetus was only formally identified as a whale when the tympanic bones were shown to be similar to that of modern whales. After the Ambulocetids came the evolution of the protocetids, which were akin to modern pinnipeds. There's no evidence that these species had a tail fluke yet, but these were the first cetaceans to leave South Asia. By the end of the Eocene epoch, the first fully aquatic cetaceans had evolved, and some of them had even grown to enormous sizes. The forelimbs had become flippers, and the hind limbs had simply become vestigial remnants, which were most likely used to assist in underwater mating. These hind limbs would have been visible in species like Basilosaurus and Dorodon. The stomach contents of Basilosaurus show that it was predominantly a fish eater. However, growing to such a massive size, it's not inconceivable that Basilosaurus would prey on turtles and other mammals like modern orcas do, but without the advanced intelligence and social aspect that modern orcas display. Today's best known whales have baleen plates instead of teeth. These are used to sieve small prey like krill so that they can be swallowed without the whale also swallowing a great mass of salt water. But all the whales mentioned in this video so far have had teeth, conical teeth. Intermediate species evolving from toothed whales to baleen whales would have bulk fed through suction, which is analogous to the feeding mechanism of a modern matter turtle. During the divergence of the toothed whales and the baleen whales, the toothed whales evolved a specialised organ for hunting in dark or murky waters. Sound travels better in water, so the toothed whales evolved echolocation. In the fossil record, this is first shown in the genus Squalodon, which in life would have been similar to a modern river dolphin. The organ consists of a fatty melon, which sits on two phonic lips. The lips produce a click, and the melon directs the sound. And this sound reverberates throughout the ocean, and it bounces back, acting like a biological sonar. And it's this organ that gives the distinctive shape to the heads of some whales, particularly sperm whale heads. These clicks are so powerful that as well as being used for navigation, they can be used to directly stun or kill fish. And if you're unlucky to be in front of a sperm whale when they produce this click, divers say it's like being kicked in the chest by a horse. This brings us to the present of whale evolution, but what does the future hold for them? Find out in part 2.